All right, the much anticipated proof of the integrated factor. Here's what we're trying to prove, right? This form showing that I of x equals this, and that d dx of this equals I times q. So here we go. Let's let dy dx plus p of x times y equal q of x. Then if I multiplied each term by some integrated factor, right, what we could then do is use the product rule. All right, now check out what I did here. Using the product rule, if I took the derivative with respect to x of I of x times y, right, if I just manipulated this using the product rule, I get the following, right? And so then I get this, right, as a result. And this piece right here, dy dx times I of x, is going to go in right here. So I isolate dy dx times I of x, which is all this blue stuff, and I'm going to plug it in right at the beginning here. Okay, so let's keep moving and see what that ends up being here. Alright, so I plug that in here. So that was equivalent to dy dx times I of x. Alright, then I'm going to rearrange a little bit. I'm going to rearrange 1, 2, and 3 in a 3, 2, 1 order here. Okay, so I see that I've got p of x times y times I of x minus the derivative of I of x times y plus d dx of I of x times y equal to qi. Now this should look familiar right here. So what I want is I want this to equal 0. So in order for that to equal 0, right, I want p of x times y times I of x minus this derivative of I of x times y to equal 0. So I want them to be equal. If I want them to be equal, then I can do a little manipulation here. It looks like the y's will just cancel. I divide by I of x, and I get this. P of x is equal to 1 over I of x times the derivative of I of x with respect to x. So now what I can do here is multiply by dx. We'll bring it over here. And what I can do then is integrate both sides. When I integrate both sides, you'll see that the integral of p of x dx is equal to the integral of 1 over I of x di of x. Right? And the integral of 1 over I of x would be the natural log of I of x plus c. The integral of p of x will equal that. Well, the integral of p of x dx plus c will equal the natural log of I of x. So we're going to drop the c and bring it over here to the left. So if I write this now from a logarithmic form into an exponential form, it'd be e to the power of this integral equals I of x. Okay, now I can use this product skill that I've got with exponentials, right? This is just a skill we have. If you add two exponents, that's just the same as the same base to those powers multiplied together. Okay, so then this e to the c is just some constant. So we know I of x equals e to the integral of p of x dx. This constant will have no effect on the equation, so we can drop it all together. That's why you won't have a plus c. Okay, so dy dx times I of x plus p of x times y times I of x equals q of x times I of x. Therefore, if this is true, what we just proved here, then p of x times y times I of x minus this equals 0. Therefore, d dx of I of x times y is equal to q times I. So in summary, what do we have? If a differential equation can be written in the following form, which we're aware of at this point, dy dx plus p of x times y equals q of x, then the integrating factor will be that. And the differential can be solved by using this. We'd integrate both sides, and that is the end. Gaines, Mark Wahlberg. Not my own proof. Glad that's over. And that's a radioactive hot dog. Peace out. That's the integrated factor proof. Just be able to execute You're not going to have to be able to duplicate that proof, so just glad that's over.